everything working? Yeah, recording. Okay. Yeah, hi. Yeah, I hope someone said to me that the left side of the left channel, so to say, is louder than the right. So I tried to fix this, but maybe it's not. Maybe it's still like that. So excuse me for having a bit rough start. Rough start. So I guess it will take a little bit of while until I get this streaming thing. And also about the streaming now, I'm doing recordings, but I have to get a cable of sorts and see how that's gonna work. So yeah. Anyway, I wanted to cover Nix language basics today. That's what I need to cover. So the Google Summer of Code results are gonna be today. I don't I'm hoping, but it's fine. Even even if they don't select me, um, it was such a great experience because I would recommend anyone to I'll just say this briefly. I will recommend anyone to sign up for these things. Google Summer of Code, because I had no idea about that, because I kind of ignored that whole thing because I thought that's only open to students, but it's not, and that's since like last 2 years. So it's open to anyone who wants to get involved with open source, and it's a great opportunity, to do some work in the summer and to earn some money, in the sense that it's kind of different, yeah. When you get paid a bit, even though it's not a bit, so it's kind of different, and the whole support like that. It's what would be the right word? Motivation, or something like that. Yeah, so it's just, and there are all these great projects. So anyway, I sent 3 proposals to NixOS. So let's see today. The Summer of Nix results are going to be on 10th. I think on 10th of May. That's like in 10 days. Okay, but Nix.dev. Nix.dev is a wonderful website. That's kind of the official NixOS documentation website, even though that might not be clear because you look at this Nix.dev and the NixOS org. So maybe that's not clear at first. But this is the official documentation website. And today I want to cover is, and these things are nice, the tutorials, guides, and reference and concepts. Fritzwerk, Handwerk. I couldn't. The main cool person that is involved with the NixOS document, the leader of the NixOS documentation team. We had a really nice lecture about these things, about this is kind of famous. Well, I'm getting lost here, but this is like kind of a separation of documentation into tutorials, guides, and reference and concepts. So I would just encourage anyone who is not sure how to begin with Nix, or kind of, like going here and there, reading blog posts and reading this and trying to, like, I've been trying to package the module, and you go here and there. It's almost like you want to rush things a bit, but the Nix.dev, the tutorials are amazing because they cover the first steps, and it's all like it's not just blah blah, like it's blah blah with explanations, and it's not too with too many words like I'm saying now with all these words, but it's really on point, and you can type things in. I mean, you can type things. It's not interactive in that sense. Maybe it will be someday, but you can type things and see how they work, and it's a great way to learn. And I thought the best way for me to prepare, also much better for the Google Summer of Code and the Nix Summer of all these summers, and not just that, because after a while you do something, you realize, okay, I really have to go through the basics, like really go through the basics. So, and there are all these really nice subjects, really nice subjects, modules, system deep dive. That's a wonderful one. Cross compilation, NixOS, virtual machines. There's like a newer tutorial here where you can start up like a virtual machine from the terminal. Like it won't, like, without the graphical environment. So just like you I think you're just staying in the shell, and you can just log into a virtual machine, which is kind of cool. Working with local files. This is a really nice, really nice tutorial that I will, although the name is like, okay, working with local files. Overrides, overlays. Anyway, today I want to go through it. I want to start with Nix language basics. So the Nix language is designed for conveniently creating and composing derivations. So now what's a derivation? Precise descriptions of how contents of existing files are used to derive new files. It's so general. Precise descriptions, but it's nice. Precise description of how contents of existing files are used to derive new files. So it's kind of like a transformation kind of a thingy. It is a domain-specific, purely functional, lazily evaluated, dynamically typed programming language. Domain-specific, purely functional. Okay, I won't go into really explaining all of these things now, but purely functional, lazily evaluated, dynamically typed programming language. Yeah, it's kind of like Haskell, but it's not. But what's really great is it purely functional and lazy. Yeah, that's nice. Okay. Notable uses of the language: Nix packages, which are the packages, and NixOS, the Linux distribution that I use right here, and underlying modular configuration. Also, so everything's written in Nix language. So that's like the most incredible thing. What got hooked me is because somehow the programming language and the system was one. Like I didn't feel that way with Bash. When I was always kind of separated. It was like me and the Linux distribution and some kind of a project that I want to work on or learn programming. But with NixOS, it's like you can just start with NixOS or with Nix, and you start to package things and you learn a language, and it's for me, and I'm just talking from my experience, that's like I felt like coming home, because you have a language and a system, and you control the system with the language, and it's declarative, so you don't have you don't repeat yourself. So everything what you learn, you can build on that. That's so beautiful. Okay, you may quickly encounter Nix language expressions that look very complicated. So yeah, it's Nix language. Everything is in expression. This has to do with functional languages. As with any programming language, the required amount of Nix language code closely matches the complexity of the problem it is supposed to solve and reflects how well the problem and its solution is understood. Building software is a complex undertaking, and Nix both exposes and allows managing this complexity with the Nix language. Yet the Nix language itself has only few basic concepts that will be introduced in this tutorial, and which can be combined arbitrarily. What may look complicated comes not from the language, but from how it is used. So this is kind of like it's interesting. Um, they are like already preparing the reader, but I find this what's complicated. Yeah, well, I'll stop talking. Using the Nix language in practice entails multiple things. Okay, language syntax and semantics. So like the rules and what are the meanings of the language. Libraries, built-ins and packages.lib, which are kind of like functions or like collections of functionalities that one can use, that one can just take like from a library and use when you want to build something, you know, or when you work on something, so that you don't have to write everything from scratch every time. So that's the point of libraries, and kind of like common functionalities that we all need. And someone says, oh, that would be good to make it like a library, and then you can take that book. Developer tools, testing, debugging, linting, formatting, 3 dots, okay. Generic build mechanism, standard MK derivation, trivial builders. Yeah, that's like, yeah, okay. Composition and configuration mechanism, that's interesting. Override and override address, and overlays. So far as I understand, overlay is like you have a bunch of packages, and an overlay is kind of like you make a change to the entire field, like field, that's not a really a technical term, to the entire set of packages, all of the packages. And override is like when you make a specific configuration change within like one package. And override address, I don't know, but that might be a wrong definition. I don't know. Ecosystem specific packaging mechanisms, build Go module, build Python application, NixOS module system config and option. So this is incredible. Like, oh my God. Like, you see, you can control your whole system with Nix expressions. Even the configuration. Do I have it? No, I don't have it. No, I have it. Right. Even the whole configuration. Wait, I can do it with bat. This bat is like cat, right? Bat is. Wait a second. Where is it? So the entire. Wait, I'll do it with bat. It's kind of let's go. Wait, configuration.net. All right. So the entire Etsy NixOS. I was never. How do you pronounce Etsy? Yeah, is it Etsy? Okay, Etsy NixOS configuration.next. So that's the file that you kind of can take control. Take control. That you define, you declare your system. So when they say NixOS module system config and option, so you see config and packages, and there are all these options like networking, hostname, NixOS. That's it. You don't have to go into the system, go into the user, go into about the change, like, and then you don't even know where do you change the name of the system. Like, I don't know where you do it in Windows. I would have to go on Chat GPT, and how do you change like how do you change the name of the system in Windows 11, the name of the system to change. Follow these steps. Oh, you see, follow these steps. Open settings, system settings, rename your PC, click about, enter new name, restart your computer. Oh, give me a break. No, it's not like give me a break. I don't want to do it. But you know how many people have to do this? And it's not declarative. Like this, you can share this and you can do all kinds of things and functionalities. So this is so much better than this. Yeah, look at this. And I think it's and in Ubuntu, use the terminal. Yeah, Control LT, host name. Change the host name, sudo host name, but so you have to enter a command, you see? So still you have to go out of your seat and do some kind of a command thing. So this is kind of different. Anyway, I won't this is about NixOS language. These really are cool from 70s, these things anyway. Yeah, so this is actually the entire file, and it took me a while to really you need to grasp this, because then the experience of learning Nix will be more fun. So the entire file is an expression filled with expressions. Isn't that nice? So it's not like there's a bunch of expressions that are named like this, and this is a file. But this is a file, but this file is an expression that takes something and outputs something. It takes imports and outputs this. You see, So beautiful. So so you see this basically. So the basically configuration.nix test.nix. Wait a second. Let's do the test.nix. Test. Oh my god, that's terrible. So we have like this. Yeah, I still haven't learned the helix thingy. Yeah, this and no, actually, it's this and this. So you see, like that's a Nix expression, and it's empty, but inside you put that's like the configuration.nix. It's so beautiful. So I mean, why am I keep on? I know this is like, oh yeah, okay, this is obvious, but it's kind of it's almost like you have to have this mind blowing moment where you realize everything is an expression, like in functional language, functional programming, and that may like ease your mental state when you run into a problem, because yeah. All right, I'll stop. Q, no, not save. Okay. So let's go check the tutorial. Okay, nix.dev, developer tools. This tutorial covers important language features, briefly discusses libraries, and at the end will direct you to reference material and resources on other components. What will you learn? This tutorial should enable you to read sorry, typical Nix language code and understand its structure. Its goal is to highlight. So this is kind of should enable you to read. That's important. So it's not like you can build all kinds of things with this, but it's really important to. I read this tutorial a couple times, but never like from beginning to start. It's like here and there. And I think it's important to really run through it and then to improvise in the sense of every example you play with it. So that's what I want to do, what I want to do now, and I think that will be the best. That's the best intro and preparation to really enter the Nix land, the Nix space, the Nix final frontier. It therefore shows the most common and distinguishing patterns in the Nix language, assigning names and accessing values. So that's like some kind of an expansion on what we read here, syntax and semantics, right? Assigning names and accessing values, declaring and calling functions, built-in and library functions, impurities to obtain build inputs, and derivations that describe build text. So that's basically what's programming, and this is cool. This tutorial does not explain all Nix language features in detail and does not go into specifics of syntactical rules. Syntactical, almost like tactical rules, syntactical rules. Does not go into specifics. All right, so we won't go too much into specifics. Okay. So syntacticals, like, where you put a dot and stuff like that. There are no dots, I think. Is there function composition in Nix? Not sure. See the Nix manual for a full language reference. So you can, Nix language, dynamically typed, lazy. Okay, so here you can actually see the definitions. Like a lazy, values are only computed when they are needed, which kind of allows us to do really cool things. Okay, there's some, okay, so this is a good to check. Okay, let me move this. What do you need? I need you. No. Familiarity with software development, familiarity with Unix shell to read command-like examples, a Nix installation. How long does it take? No experience with functional programming, 2 hours. How did they get this number? I remember when I saw it the first time. Like, how do you know? Familiar with functional programming, 1 hour. Proficient with functional programming, 30 minutes. I mean, I think this is more like general. I don't think they made a test. We recommend to run all examples and play with them to validate your assumptions and test what you have learned. Read detailed explanations if you want to make sure you fully understand the examples. Okay, how to run a piece of Nix language code is a Nix expression. Evaluating a Nix expression produces a Nix value. The content of a Nix file is a Nix expression. Everything is in a Nix expression. So a piece of Nix language code, I think this is like when you learn Haskell, like a piece of Nix language code is a Nix expression. The entire language code is a Nix expression. Yeah, I think that I don't want to now enter into the debate. Like, would you say a bunch of Nix expressions? But actually, since like the entire code is a Nix expression because it starts from that, it builds from that. Like then our configuration.nix, the way the code is formed, it starts from like an empty expression, and the empty expression expands into Nix expressions. So in some sense, the file itself is a Nix expression, like a category of all categories or something like that. Not sure. Evaluating a Nix produces a Nix value. The content. All right. To evaluate means to transform an expression into a value according to the language rules. To transform an expression. This is nice, to transform. This tutorial contains many examples of Nix expressions. Each one is followed by the expected evaluation result. The following example is a Nix expression adding two numbers. All right, let's start. Yes. Nix REPL. Welcome to Nix REPL. Type for help. Load Nix Flake. Reload Nix Flake. Describe result of an evaluation. Build. Oh yeah, where can we see types? Types, string. No, types, T1. An integer, string. A string. But can we see like how the type is built? U build and start Nix shell. E build a derivation. B, so evaluate and print expression. Bind expression to a variable. X expression. Bind expression to a variable. This is interesting. Bind, I'll take some notes because I'll take some no issues. This is something what I've been, yeah, wait. Notes. Notes, wait, this is notes. Bind expression to a variable. Next. Yeah, this is something that I was on the Matrix channel about this yesterday. I made a recording also, but the sound was not good. It was still on the left more, so I didn't upload it. But I'm uploading this one because I said I will record how I work. So, there was an interesting discussion because I saw let expression. Yeah, this thing. So bind expression to a variable. What do I mean by that? So like x equals 1. So it's like you're never sure what does that mean? X equals 1? Is it x is 1? X is 1. X yeah, right. X equals 1. I almost feel like, or x or 1 is assigned. What? 1 is assigned to x. Okay, I don't like the word assign. It's not, I don't like. This is not about me. But the assignment is like, it sounds impure because the state can change. Or binding x to 1. Binding. So it's kind of an interesting. Maybe I'm going too deep now for the beginning, but x. So let's come back to this. Actually, I want to come back I wanna also mention this. So the following example is a Nix expression adding two numbers. So you can use this to, like a calculator. 1, 2, 3, 1 plus 3. And I think it respects, like all these kinds of, oops, this is not even math. Yeah. Plus, minus 3, minus 2. So you can do all these things. I don't know. Can you do like 1 plus 2 equals 2 plus 1? No, unexpected. Yeah, because 1 plus 2 equals is this. This sign, the double equal sign shows the equality. It tests the equality. So this is true. It's almost like saying, can we say like an apple equals a pear? False. It's not. Apple equals an apple. True. All right. And 1 plus 2, that's 3, right? So let's do 6 minus 3. True. That's true. All right. Anyway, 1 plus 2 and 3. Interactive evaluation. Use Nix REPL to evaluate Nix expressions interactively by typing them on the command line. Okay, so we are in Nix. Well, this is 2.13. What do we have? 2.18, I think it was. Nix REPL 1 plus 2. Okay. The Nix language uses lazy evaluation, and Nix REPL by default only computes values when needed. Some examples show a fully evaluated data structure for clarity. If your output does not match the example, try appending P to the input expression. What does this mean? Lazy evaluated. It means like it doesn't have to compute the whole thing. Let's say I give you a book. You have this whole book filled with things and you want to learn about this one thing. So you open and you find that one thing and you get that one thing. But you don't have to read the entire book just to get that one thing. Like sometimes programs work like that. Like it evaluates the whole function and then you get what you need. So it runs the entire calculation. It runs the entire thing and then you get what you need. But with this, it gives you what you need and it does not calculate the entire thing. That's why it's called lazy. Which is kind of a nice thing that's called lazy, because usually lazy is in negative sense, and with functional programming lazy is such a positive word. So I applaud this. I applaud this because it's kind of like transforming the meaning of the word into that it's not like a bad word being lazy. Maybe that's just me now. Maybe that's not even. Yeah, okay. Some examples show a fully evaluated data structure for clarity. If your output does not match the example, try appending P to the input expression. Example, ABC. Okay, this is an attribute set. We can try that later when attribute sets come. So, but you see this ABC1, A, and you get A, Nix REPL, P, ABC1, and it runs the whole thing. Yeah, but it's not clear with this. Yeah, okay, it's clear, but it's maybe the concept of a laziness. All right, let's. These are my kids. Okay, evaluating Nix files. Use Nix instantiate eval to evaluate the expression in a Nix file. Echo 1 plus 2. Echo 1 plus 2 into file Nix. All right, let's quit. Where are we? Let's go to dev. Dev is just a directory I made. What do I have here? Nixtut. Nixtut. Okay, let's default Nix. That's what I've been doing yesterday. Let's remove that. And my val remove. All right. So echo 1 plus 2 file.nix. Yeah, I already have it. Echo 1 plus 2 file.nix. And Nix instantiate eval. Yeah, I already have it. Look, Nix instantiate eval my val Nix. File.nix. So Nix instantiate eval file.nix. It's 3. So we So we run 1 plus 2 into file.nix, and we instantiate it, we evaluate it with Nix instantiate. So it's like, this is like going into REPL and doing 1 plus 2, right? It's 3. But this is like, you don't have to go to the REPL. You can just, you know, or you can have a file. This will be used later when you build actually packages. So, right, you write a definition and you Nix instantiate it, right, into a derivation of sorts, or you realize it. There are all these terms. Yeah, there are all these terms coming up later. Also, I made nix.repl, nix, so that I don't have to type all this time eval. I will be using NEE, which are just like, ls, ch. ZS, ls, no, wait, bad, let's try like this. So I put in alias alias NEE. That means Nix, that's how you put in alias, Nix instantiate -- eval, so that I don't have to type this every time, even though I have autocomplete in ZH in my shell. So I just NEE. So this is I think this is good to put you in your shell configuration file. You can put in alias, so that way you don't have to type every time. Yeah, let's move on. The Nix language uses lazy evaluation. Now it's showing the lazy evaluation like this with files. And Nix instantiate by default only computes values when needed. Some examples, so that's nice, right? It computes when needed. It even sounds nice even if you don't understand. That's kind of cool. Even if you don't know what that means in programming terms, it's kind of, okay, that makes sense. Computes values when needed, right? I mean, it does make sense, even if you don't know anything about programming. Some examples show a fully evaluated data structure for clarity. If your output does not match the example, try adding the strict option to Nix instantiate. Example, echo ABC, ABC1 binds, yeah, you see this binds to 1, to the value of 1, file.nix, goes to file.nix, echo. So you see echo now it's putting in the strings, and Nix instantiate eval, file.nix, a code, you get this code thing. So it means it outputs a, it shows you that it, it evaluates that and it shows you the set of A, and these are like subsets, A, B, C. So wait, you can see that, you can format this. Wait a second. Pretty print me this Nix expression. So ABC, no, not like this. No, like show the subsets in a separate line. Nested manner, yeah. So right, so you see this, okay, right? So that's this actually, right? This A, B, C, A dot B dot C. So it's like A and then subset B and then subset C. So this is how you structure code. This is one of the ways how you structure code by nesting. I don't know, I would just wonder how, like, this is interesting. Are there any other ways to structure code? Like, this sounds like a pretty basic way to structure code, nesting. Like, how many abstractions can you do just with nesting? You can just nest things. Yeah, anyway, okay. Notes on whitespace. Whitespace is used to delimit lexical tokens. So yeah, wait. So Nix instantiate eval file Nix, and it shows you A. It shows you A and then some code. So the A has all this subset and the value 1, but it doesn't compute it, right? You evaluate it in A code, but if you want to really evaluate it, the entire set and subsets, it shows you this. It shows you the structure, which is very nice. Notes on whitespace. Whitespace is used to delimit lexical tokens where required. It is otherwise insignificant. So this is a wiki now link to lexical tokens and lexical tokenization, Wikipedia. All right, this is also an interesting lexical tokens, and I'm doing something. This has to do with Google Summer of Nix project with parsing languages. That's a whole nother thing. Parsing languages and tokens. It is otherwise insignificant. Line breaks, indentation, and additional spaces are for readers' convenience. The following are equivalent. Let x equals 1, y is 2 in x plus y. And that's 3. Let 1, this is just about how to write what things, but that you can write them like this or in one line. Let x. So that's the let thing is like anyway, we'll get to let. Let comes also. Okay, names and values. Values in Nix language can be primitive data types, lists, attribute sets, and functions. We show examples of primitive data types and lists in the context of attribute sets. So values can be primitive data types. And lists, attribute sets and functions. We show examples of primitive data types and lists in the context of attribute sets. Later in this section, we cover special features of character strings. So this is how to manipulate strings. String interpolation, file system paths, and indented strings, we deal with functions separately. So strings are just strings of, letters. Character like a letter and string like a word. But the word and letter, it's not so abstract. It's too general. So string, yeah, okay. Attribute sets and let expressions are used to assign names to values. Assignments are denoted by a single equal sign. Single equal sign. Whenever you encounter an equal sign in Nix language code, on its left, sorry. Okay. What? Okay. Whenever you encounter an equal sign in Nix language code, on its left is the assigned name, on its right is the value delimited by a semicolon. Attribute set. Wait, sorry, I got now. Whenever you encounter an equal sign, on its left is the assigned name, on its right is the value delimited by a semicolon. All right. Attribute set. An attribute, so there are like a bunch of definitions now, but an attribute set is a collection of name-value pairs where names must be unique. The following example shows all primitive data types, lists, and attribute sets. Okay, this is similar to Nix and JSON. Who knows that? This is kind of practical, but you can see, like, we've seen this structure when we write notes, like this and this and this, and then like subset. This is okay. Attribute names do not need quotes. List elements, okay. Recursive attribute set. So there was already an attribute set. Yeah, it would be nice there was a code here, actually. Okay, there's code here, attribute set. Okay, recursive attribute set. You will sometimes see attribute sets declared with rec prepended. This allows access to attributes from within the set. So an attribute set would be like, attribute set equals 1, 1 equals 1, right? 1 is 1, and 2 equals 2, and that's it. So attribute, and now you have like you see, like you have some kind of a data structure, or you can have what would be a nice set of years, like set of family look, you see, this is less family age, and dad equals, I don't know, 39, and mom equals 31. I don't know. I don't know if is how old is my wife? 91, 33. She's 33, and son is 3. Right? So no, this is, oh yeah, I made an error. Wait, this. So family age, dad. So this is actually a bad naming. I can't name this family age. This is like family members age, right? This is like family members age. Family age, dad, mom, son, and then you just I guess you can do family age dot son. Yes, 3, and then you can do family age dot mom, 33. Family age dot dad. So this is what you do later with, packages. Now it's really simple. We're not putting any functionality within the attribute set. So it's like the attribute set itself will have functions within, and the functions will have more functions, and function will have more functions. So then it becomes a little bit complicated. But now it's just with names and values. All right. So that's a family age. Dad 39, mom 33, son 3. So a recursive attribute set. This is cool. You will sometimes see attribute sets declared with rec. This allows access to attributes from within that set. Access to attributes from within that set. So this may not be clear. So it's like the attributes themselves could access themselves inside of the set. So this example is kind of clear. Rec 1 is 1, 2 is 1 plus 1. So it's calling the 1 above, n plus 1, and 3 is calling the 2. So you cannot do that. You cannot call those pairs. The pair cannot call another pair. So you cannot call recursively, right? You cannot reference or recursively call the other member of that set, which is kind of, so like if we see this example, family age, so we will have to add rec. So that probably means family age equals, let's try to build this, rec, and now dad equals 39, all right, and mom equals mom is dad minus what's that, 6, minus 6, and son is mom minus 30, yeah. So you see, dad is 39, mom is 33, which is dad. So I'm calling recursively. I think this is a, wow, this is actually this might be even a better way to learn recursion. Recursion is really complicated because you have the thing calling itself all the time. But with an attribute set where you have like more things in the set and they recursively call the other thing, so that's more intuitive. And usually recursion is sometimes explained in a sense that an object is calling another object, but in like kind of like cutting bread, or like I forgot the example with the dragon and the bread. There was this anyway. So this sounds. I think this for me at least. So right, dad is 39. Mom is dad minus 6, and son is mom minus 30. So you might say, but what's the point of this? Well, there will be problems where you need to do this, right? You need to do this, like, and because it depends on this, on that, so then you use that. So, right, let's see, family age, and it works. It works. Let's call this family age rec, right? It works. And the other one, family age. All right, so family age rec A. No, rec dad. Did you mean dad? All right, so he can inspect this. 39. Let's see, family age rec. Does it work, mom? 33. It does. And if I did the same thing, all right, if I did the same thing without the rec, it wouldn't. Undefined variable dad. You see, it started here, dad undefined, because I didn't define it. It cannot do that, right? It cannot see, oh, dad is there. You see, it does not have that functionality. So that's kind of cool. Recursive, and we do these things in real life. I don't know. I would have to ask ChatGPT to give me an analogy of a give 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 me a simple analogy of a recursive set in Nix in real life. So one of the things that I learned is that recursive or rec is a anti-pattern, which I still have to learn why, but it has to do something with evaluation and the time it takes and everything, which might, there might be actually better ways to do the same thing. It's not like the pattern itself is bad, but I guess the way it's implemented, there are better. Family tree analogy, all right, top level. Family trees are great because, we have families, so we can, we can connect to that, bind to that. Top level, family name, consider this as the root, represents the root of the Nix set, might encapsulate all subsets below. Individual family members are nested sets and different relationship, the parent, grandparents, how it relates. Example in Nix, okay, John, relation, children, Michael, relation, father, but, oh, the structure recursively nests each generation, align complex. Is that a rec? Did he do a rec? No. Show an example with rec. In Nix, the rec keyword is used to give recursive family tree in Nix. Family, all right. Family rec, family name Doe, John. Relation grandfather, children, Michael and Lisa. And then Michael, relation father, parent John, children Sarah and Emily. Parent John. Parent John. All right. So rec. So we have like the first and John, we define John and family name, right? And then we have the second, Michael, and the parent is John, so it's calling John, right? So if you did this without the rec, it would say John undeclared. So the way that each member of the family tree can call the other one, so that's a recursive attribute set. So next time when someone shows you a family tree, oh, that's a recursive attribute set. How nice. No. Wait, let's move on. This is taking long, yeah. In my case, the tutorial was going to take a whole day. Okay, 1, 3, 2. And here is a nice example because you can, yeah, numbers are always a great example, but sometimes too small example to really see the, it's kind of, the family tree shows something tangible, and this is like 1 and 1 plus 1 and 2 plus 1. Okay. Elements in an attribute set can be declared in any order and are ordered on evaluation. Counterexample: 1 1 2 1 plus 1 3 2 plus 1. It won't work. Yes, this is what we showed. Okay, let and in, also known as let. So this is about scoping. So also known as let expression or let binding. Let expressions allow assigning names to values for repeated use. Yeah, the tutorial uses the name let expression, uses the name to assign. So that's what I checked with the NixOS documentation channel. So you see, I asked, also known as, write this, right? I was doing this, also known as let expression or let binding. Let expressions allow assigning names to values for repeated use. I see the word assignment is used a lot in the Nix tutorial on NixDev. I'm curious, why not bind or binding? So most people are probably familiar with the concept of variable assignment. Yes. I see Elko. So Elko Dolstra in he's the one who made Nix, right? He uses the word assignment twice in his thesis and binding more than 60 times. That's like me just running a simple search. Oh, I didn't really read the whole thing. I should read it. I know. I'm like, okay. But now you have to really prepare to read it. You can just take it and read it. But I guess you need some time to, manifest that motivation. How do you say? I probably say assign more often. One difference is you assign a value to a variable while you bind an identifier to a value. This is really cool. So different, you assign, and that was, it made me think. It made me think, and yeah, this is the example that I asked. This is cool about let. So right, you see, like x equals 1, right? Let's do x equals 2, right? X equals 3. So what's x? If you do that, right? We are used to self-destructively change the self-destructively. To destructively change, like x is like, it's like when we say it's gonna be this. No, it's gonna be that. It's gonna be this. Like, what's the time? Okay, time is a nice example. What's the, wait, it's like when you say time. Okay, time is what? No, date is this, and now date is this, and now date is this, and now date. You see, it changes every time. When I say what's the date, the time and the date changes. It always changes, right? So when we say x is 1 and then x is 2, and what's x? X is 2. It's not anymore 1. So, but this is not like in other languages, right? Let's change the scope. So this is a very general scope. It doesn't say anything. We almost like have a dot. X is 1. But what does that x mean? Like, what do I do with it? It's just x is 1. It's like it's like a dot. Dot in the sense of, you have a dot, but you don't know what to do with it. You have to connect it to something, and then you'll have a line, and then you connect that line with more lines, and then you have like a shape. So okay, so x is 1. So with the let, we have let x is 1 in x. So let assign names to values for repeated use. So detailed explanation. Assignments are placed between the keywords let and in. Let and in are the keywords, and these are the assignments. So like x is going to be 1. So then you could do let x is 1, y is 2, c is 3. All right? You could do that, right? But you cannot do in what? In x. That's a mistake, right? You have to do in x, y, and c, because you declare them here. X is 1, y is 2, c is 3 in what? X, y, c. So you could, that's a mistake, right? I forgot, you see, those are syntax mistakes. No, it's wrong. Let x is 1 in x, y, c. Oh, maybe I have to put this one. No. Syntax error, unexpected end of file. X1, Y2, C3 in XYC. Oh, an attempt to call something which is not a function but an integer. Oh, let's see. Do you see? Wait. Let A1 in A plus A. I cannot just, you see, I cannot just put them here. Maybe only if it's a list. I could, would that work? In XYC. Oh, you see this? Because it's a function. Everything is a function in Nix. So when in Nix, like in Haskell, you have X and Y, undefined variable Y, but like X is applied to Y. This is not clear what I say. Okay. So but look at this. Let X is 1 and Y is 2 in X plus Y, right? That's 3. So the scope, but now what's the X? X is still 1 that we declared from before, right? Let X equals 1, let X 1 in X. And X is 1, right? And now write X is 2. Okay, wait, this was not clear. Let's say X is 100, all right? So X is 100. And now I write let X is 1 in X. So X is now 1. But X is not now 1. X is 1 in this let expression. And the expression is anonymous because it's called an anonymous because we cannot call it anymore, right? I will have to call it again, the whole thing. I cannot just not call it by name. I would have to give it a name. So name, let's call it a name. So name equals let X equals 1 in X. So you see, it didn't compute it here. Here you see the lazy evaluation. So when it was anonymous, it already outputted the value of X, and now when we gave it a name, it doesn't output it because it has a name. So it's cool, we can call it. So now when I call it name, it gives me the value of X, which is 1, and X is 100. X is still 100, so right, so it's a different scope. This is the question of scope. So like two things can coexist together because they have a different scope, right? Okay, yeah, hope that makes sense. Let A1 is 2. Assignments are placed between the keywords let and in. In this example, we assign A1. After in comes the expression. So after in comes the in X, comes the expression in which the assignments are valid, where assigned names can be used. In this example, the expression is A plus A, where A refers to A is 1. By replacing the names with their assigned values, A plus A values to 2. Names can be assigned in any order, and expressions on the right of the assignments can refer to other assigned names. So we can do like in the recursive attribute set. So we can say what's the example here? Okay, we can do like let B equals A plus 1. Let B equals A plus 1 in A plus B would be wrong because A is not defined, right? Undefined. B is defined as A plus 1, but what's A? We don't know. So let's let B equals A plus 1 and A is 1. So the result of A plus B is going to be A is 1 and B is A plus 1. If A is 1, that's B is 1 plus 1 is 2 and 2 plus 1 is 3. So it should be 3. Yeah. All right. But we can say like let, well, that's with strings. All right. Would that work? Let name equals Domagoy. And Domagoy. And age equals, well, that's just age equals 39, and name plus. I cannot add the thing's name plus. You see, how do you age? No, this is wrong. Cannot convert as integer to a string. You see, you cannot just add an age to an integer because the computer doesn't know what to do it. And if I put it in a list, let's try things. Name and age. All right, I can put, so a list can have different types. It doesn't have to be the same type in a list. I think in Haskell, right? The list has the same type. Yeah. Domagoy and 39. So you see, you can group things like this, and then later the functionalities, right? You start to build things. All right. Detailed explanation. Assignments are placed between the keywords let and in. What's the time? Oh. How long is this thing running? 1 hour already. Oh wow! I didn't even start. Yeah, today is the May 1st, and in Croatia, that's the day where people don't work. Most people don't work. It's like the free workers' day. I think even from socialist times. Probably more countries in the Europe has the May 1st, the National Workers' Day, the World Workers' Day. I don't know. So my family, I stayed here just to make a little stream, and then I'm gonna go with the car and go meet them in the um, and a little bit outside of the town. There's this nice place, and like where there's a lot of nature. Okay. Does not therefore the assignments reverse is equivalent. Let a equals 1, b equals a plus 1 in a plus b. All right, let's just note that a is in b, a plus 1 refers to a is 1. Yes, that's what we did. All right. This is similar to recursive attribute sets. Yes, what we said. In both, the order of assignments does not matter, and names on the left can be used in expressions on the right of the assignment. Let in and rec. Oh. So this is like rec and let. Yes, but let is like for function. It has like, you see in, and here you write an expression that will kind of make some kind of a function that will do some kind of a computation, and rec is kind of like declaring a structure. This is a structure also, but it's like it has functionality within. This is the value, 1 plus 2, it's the same value. Oh, look at this, it computes the same, it outputs the same value. C equals C, A equals A, B equals B. C equals C, A equals A, and B equals B. Why is it C, A, B? A, B, C. Does it sort it? Does it sort it? This is interesting. Let Nix. Let's do let, no. Let Nix. All right. Let's save it. And let Nix. A1, B code, C code. All right. If we add strict to it though, A1, B2, C3. Oh, so it does sort the, you see, like, what if we add, it sorted it, A, B, C. I didn't know that. Like if we change this to A, previously defined here, duplicated key. This is nil. I have it in Helix. It's great if you can get a language. What's it called? It's nil, and so Nix Language. I forgot now. Nix Language. Yeah, so that you have. Okay, I'll talk about setup some other time. Uh, this is A, and let's change this to B, and let's change this to B. Oops. And let's change this to C, and let's change this to C, and let's see now how it goes. And it's the same thing. Yeah, it sorts it. So the let statement, the output of the let statement in Nix sorts the keys. Yeah. Another thing what comes to, it's what kind of a, so the attribute set is a, this is great to this is what I read in the this is what I read in the, so Bartosz Milewski categories theory book. He's really amazing. Category theory for programmers. So you have this partial order at the beginning of the book. It's really great book. I don't even understand it, but partial order, asymmetry of home sets. Wait, he partial order. Yes, orders. Order, simple graphs. So I'd encourage, like partial order, total order, and pre-order. These are really interesting ideas to check. Like, how do you sort things, but in a really general way? Like, what does that entail? Like, what's actually, uh, what does that look like? So, what kind of orders you have? You have these three, so there are only like three types, like partial order or total. Finally, you can impose the condition that any two objects are in a relation with each other one way or another, and that gives you a linear order or total order. So you can completely order things. Like if you have, if you want to order people by height, and if you can really look how high each one, no person is the same. Like if you go to a micron, and you can line them up, and that's a total order. What Nix store is, and Nix packages, or the attribute set is a pre-order. No, it's a partial order. You can have a stronger relation than pre-order that satisfies an additional condition than if A less or equal than B and B less or equal than A. I'm always confused with this. Then A must be the same as B. That's called a partial order. I would definitely check more of this. I won't do that now because this is something that I like read and try to understand. But it's the best thing was to do to ask ChatGPT as some kind of a analogy, like give me an analogy. Yeah, let's for partial. Okay, let's because that's the structure and Nix. That's the structure of Nix attribute sets. But yeah, give me something from real life. Partial order is a concept from mathematics. From order theory, elements are comparable to each other and some are not. So what does that mean, right? To find a real-life analogy that represents a partial order, consider the hierarchy and structure found in corporate organization chart. Oh. Yeah, the ChatGPT one time gave me an example like of like school. You can take a subject and that subject has a requirement of another subject, right? You can't do this before you do that. But at the same time, you can do another subject that is not related to the first. Like to do math 3, advanced math, you have to do basic math. But at the same time, you can do, I don't know, like Japanese, right? It does not depend on whether you have math or not. So Japanese is kind of not in that lineup of math. So that's why it's called a partial order, right? With total, when you line up people by height, no one sticks out like that. You can line up everyone and everyone will have their place in the line. That's a good example, right? And the corporate organizational chart, just like a partial order where some elements are comparable under a specific relation, in a corporate chart, some employees are directly comparable in terms of their reporting structure. A manager is above an assistant, right? In a partial, not all elements need to be comparable. Some might not have any direct relation. Sometimes, similar in a corporate chart, an employee in the marketing department may not be comparable in hierarchy to an employee in the finance. Yeah, that's the thing. Anyway, that's a great book also, Bartosz Milewski, Category Theory for Programmers. You might not understand it at all. He has lectures on YouTube also, but it's inspiring really to just hear that, and you can, because the vocabulary is so rich. So it's kind of nice to listen to a very rich vocabulary. Yeah. Do I sound elitist when I say that? I do not wish to sound elitist. Yeah, I'll have to go soon. Wait, where are we with the difference following? All right, this is only expression within the let expression itself can access the newly declared names. We say the bindings have local scope. The bindings have local scope. Counterexample. A equals let x1 in x, b is x. Error, undefined variable x. Oh, that's the example from before. So, Nix REPL, right? If you say let x, okay, let x is 1 in x. Let x is 1 in x. And if I write b is x, and let's say I'll do b is 2. B is 2 and x is 2, right? So how do I compare that now? I cannot compare it because it's not in the scope. Yeah, I cannot compare x with a b. Yes, I cannot compare. If I do let x equals 1 and x, I cannot compare b equals x. B equals x. Yeah, I can be true because I wrote x is 2. Let a equals 1, a equals 0 in a 0. And so let's do b, and let's do c is 0. And let's do c equals a. False, because it does not know a. The scope is gone, right? Now it's clear. Yeah, the scope is gone. Let a equals 0 and c is equal to a. No, it's because undefined. It's undefined, right? The scope is different. But within the scope, if we write let a equals 0 in a, and then c, we'll have to define it now. Oof, I don't know how to do it in one line. But here is actually written a is let x is 1 in x and b is x. So that's obviously error, undefined variable x. Oh, this is the same example what we did, but he gave names to it. This is let. This is the same example what we did. A. Okay, a equals let. Let's do it like this first. First equals let a equals 0 in a. All right, and second is a. Undefined, right? Because it does not know about the a, right? Second is a. Even if we do second, even if we do second equals to first, second is undefined, right? Second, well, if we do second first because we named it, then it's gonna second it's gonna be also 0. Here is b equals x. He didn't, if he wrote b equals a, then it would work. Yeah. Error, undefined variable x. Attribute access. Okay, so here, well, this probably may not be all clear, but it's good to play with it. Good to play with it and try it out. So it's never just read it. Never just read it. Because it's important to play with it. And even if you conceptually understand what's going on, you need to play with it to like stretch things out. It's almost like knowing a dance move. Okay, I see it, but you have to do it, right? You have to practice it. And even if you know the dance move, if you are in a different step, you'll get lost. You really have to know the dance move, right? Why am I talking about dancing? Okay, I like dancing. Attribute access. Attributes in a set are accessed with a dot and the attribute name. So that's what we did before with family age, right? Is that thing on? No, it's not, because I went out, right? Family age, dad, it's gone, right? Because I saved it, but then I went quit, right? And then you go in, and now it's gone, right? So even the, like if I do a equals 1, a is 1, right? I do quit and I go back and a equals no more a, right? It's gone. It's like an anonymous rebel. Accessing nested attributes works the same way. Okay, so it's like let, what is it? Ah, it's giving let x is 1. This is nice because before I was showing like let x is 1 in x, right? I did let x is 1 in x. That's 1. But he's doing here she, the tutorial. The tutorial is doing let attribute attribute is x is 1. Oh, because it's an attribute set, yeah. 1. Oh, this is it. Can you do this in one line? In attribute set x. It does work, so that we don't have to write it. It's just, yeah, it's a little bit more it looks better like this. Let attribute set is what? X is 1. In what? Attribute set x, so it gives you 1. So our previous example was let family age, family member. Let's do it famem. Let's do famem, like family member. Family member equals dad. Dad is me, Domagoj. Me, mom. Let's just do mom and dad. Right? Family member. Let's just do dad. Yeah, okay, wait, I'm just complicating now. Mom, Linda. Mom, Linda. Fam member. Dad, Domagoj, mom, Linda. Right? In attribute in what? In fammem dot, and now who are we gonna call? Dad or mom? Dad. And it gives me Domagoj. These are really simple things. It's like making notes. You write notes and then you open the notes and you take the information you want. But here is represented in code. All right, this is like basic programming because you can, okay, yeah. Accessing, 10:05. Do I have to go? Wait a second. How long is this? 1:19. Wow, this is long. So where am I? Accessing nested attributes? Oh, accessing nested ones. A, B, C. Okay, this is the same, but it looks a bit complicated, but it's not. It's just the same when we nest them. So like if I had B equals C1. And then you call ABC and you're calling the C, right? It's 1. This looks a bit more complicated, but it's the same. The dot notation can also be used for assigning attributes. Assigning attributes. ABC is 1. Oh, and you assign, so you basically do this with ABC is 1. So like you could do, that's like name, age, what's this? Name, age, position. Name, age, position equals doorman. Doorbeller. What do you, wait a second. Teacher, right? Right? No, it should be here. So name, age, position, teacher, right? So look at this. So now I have name, but if I wanna access teacher, I would write name, age, position, undefined variable name. Oh yeah, I would have to do so wait, let's try this. Set, we call it set, and then we do set. Wait, this is, let's do organization. Organization. So name, age, position, teacher. Yeah, this is too simple, but it's like now I could do organization name. I'll see under name comes age, and if I do organization position, attribute position missing. So I have to write everything. Organization name, age. Organization name, age, position, teacher. Oh, organization name, age, position, teacher. That's like what we have in the NixOS configuration.nix. We have like this, and then enable, where you have like X server display manager, I don't know, gnome enable true, kind of like that. Then we have with. Let's end with with. Let's end with with. All right. Thank you for watching, and yeah, I'll continue. It really helps me to work. It helps me too to work like this. And I don't know if I said this, but one of the reasons I think this is cool, and it would be nice if everyone streamed, not because everyone should watch everyone stream, but I think, I don't know. I'm not too familiar with this, but like, will the LLMs, like ChatGPT and stuff like that, when they start can they take the data from videos? It would be cool if they could like take all the data from all the streams and then really help you when you have a problem with Nix, right? Because so far they scan like the tutorials and the manuals. So I guess they'd need more data, right? That would be cool. So they would probably be able to help you. So that's kind of like a motivation that I have for streaming and for recording, because maybe it will be beneficial. Not directly that everyone just, watches my stream, who has the time, but maybe it will be beneficial, later with the artificial intelligence, stuff like that, I don't know. Thanks for watching, and